Hey guys, it's me Percy Vishal, and I'm a TTV student, and today I'm showing my project for the competition thinking with the data science, and I was assigned to do a building an interface to enter the concrete mixture and the return and estimate the strength, and I have done that. I will show you the project here. Let me open the camera, and these are the libraries that I have input here to perform these tasks. And previously the data was in the Excel, but I was having trouble to do that to perform the task, so I just changed it into the CSV file, and I just read that CSV file, and you can see the result over here. And I just changed the name of the columns by using that data rename function, and by putting the head we can see that it print the first five columns and row, and x are the variable and the data for the cement blast furnace. Y is also a variable for the data concrete strength, and I have used a random forest regression because it is very useful tool for predicting any input for the continuous numeric values when we input. And 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 this ticketer is used for GUI graphic user interface, and I have used this canvas for displaying image and displaying the image. And these are the variables that the entry cement, entry slag, and entry flies, entry water, entry superplaster, that will be used to input the value for performing the task or predicting the concrete strength. And these are the labels that we assign for the assign for that interface cements, and this is the value that we'll have to input. And this is also for like making a good like making a good labels or like the title like that. And these are the code that I just do for predicting the strength. And at last I just use the main loop or the get function to perform the task. So I will just run all the programs. And this is the interface that I create by using this program and code. Let me put the value like which is on the third row 332.5 142.5 0 water 228 0 932 fine aggregate 594 is 270, which gives the value here 40.49. That is the value that we got from this project. And also I have done the literature research, we can see here. And after reading the study reference like 1 2 and 3, these are the research that these are the literature that I create research on the high performance. I just want to explain this. Research on the high performance concrete is HPC shows that workability and the rheological property play a key role in mixed design. Engineers test concrete workability with a slump test, but this approach doesn't work well for very fluid or steady mix. Early stress and the plastic viscosity um, give the clear insight into the workability with adding stress linking more slump values. Devices like the BTR HOM measure this factor better for the high performance or um, self-compacting concrete. Research backs up that early stress affects slumps while viscosity changes the follow rate. What goes into the mix of the superplastic and silica foam has a big effect on this trait. Also, using computer model such as the comprehensive packing model makes uh, mixture design more accurate. The lets engineer predict how the concrete will behave when it's fresh and after it's hardened. This new method helps to find the tune especially for the building project that need high strength, long lasting material and easy to work with the concrete. And this is my project for the concrete strength, and I hope you like it. And thank you. Have a good day.
9, we decided to do the concrete strength option for our project, and I was in charge of um, getting the estimates based off the data that we had, so we could make estimates based off of given data. So the second function that I made has it handles all the inputs, so someone can actually input their own data. And then the first one is actually plotting the regression. So we have an estimate based off of each of the values from the data, whether it's cement or ash or water. So if I run it really quickly, what the plot looks like for all of the data for cement, and then if I enter amounts for each of the given values, then we receive back the estimated concrete compression strength.
Hi, my name is Latasha and I'm in Group 9. For Group 9, we decided to do the concrete strength predicted. So in my part of the project, I had to do the database acquisition, the exploratory data analysis, and I also built one data model. To start off, we had to import all the libraries that was used throughout the entire project. And then for the database acquisition, I wanted to load the Excel file into a data frame. And then we wanted to read and display the first 10 rows of the data frame. Using the info and describe function, we got the information of the data frame, and then we got some statistics from the data frame. For the exploratory data analysis part, I wanted to reformat the column. So I reformatted that column name so it's a little bit easier to use throughout the project. And then we use the correlation function, and we use the seaborne function to display a correlation heat map amongst the various variables of the data frame. I wanted to display the correlation between each variable using the seaborne pair plot function. And then we use the seaborne scatter plot function to display a plot amongst cement, water, and age, the effect on the compressive strength too.